Hi, my dear students. Welcome to India's biggest online platform, ME Educational Institutions. In this session, we can solve some problems based on thermodynamics. Let's start the session. Read the question carefully. A rigid nitrogen tank stored inside a laboratory has a pressure of 30 atmosphere at 6 a.m. when the temperature is 27 degrees centigrade, and at 3 p.m. when the temperature is 45 degrees centigrade, the pressure in the tank will be dash atmosphere, nearest integer. This question given in JEE Mains 2022 shift 2. First, try to read the question and understand the given data and try to write down complete given data, then apply your fundamentals of thermodynamics to solve the problem. First, read the question carefully. A rigid nitrogen tank. A rigid nitrogen tank. The term rigid is given. That means volume is constant. Volume of the nitrogen tank is not changing. They recorded pressure and temperature at 6 a.m. and 3 p.m. I am taking 6 a.m. as initial conditions, 3 p.m. as final conditions. Here initial pressure will be 30 atmosphere, initial temperature 27 degrees centigrade. At 3 p.m. that is the final state of the gas, because we are analyzing the nitrogen tank between 6 a.m. and 3 p.m. Temperature 45 degrees centigrade, then what will be the pressure in the tank? So see the given data in the proper manner. See here, parameter, what is the initial pressure? Pressure at 6 a.m. 30 atmosphere. Temperature at 6 a.m. 27 degrees centigrade, and final temperature 45 degrees centigrade at 3 p.m. Final pressure at 3 p.m. What is the pressure of the gas present inside the tank? Understood now? So that part we need to calculate. What is given in the question? A rigid nitrogen tank. That is why volume is constant. Volume is constant, then pressure will be directly proportional to temperature. So here I want to convert degree centigrade into absolute thermodynamic scale, that is Kelvin scale. Okay, so here what is given? Tell me. T1 equals to 27 degrees centigrade. How to convert it into Kelvin? 27 plus 273 equals to 300 Kelvin. First try to convert entire part into these two temperatures into absolute thermodynamic scale. 45 degrees centigrade, here it would be 45 plus 273. Here it is how much? 5 plus this 8, and then 270 plus 40 will be 310. So 318 Kelvin. I converted initial and final temperatures into absolute thermodynamic scale. So if volume is constant, here volume is constant, then pressure is directly proportional to temperature. Pressure will be directly proportional to temperature, then P equal to some constant into temperature. So I can say that this, you can say constant generally in thermodynamics, this is the constant. P by T equal to constant. P by T equal to constant. Then I can say that I can directly write here P1 by T1 equals to P2 by T2. P2 by T2. So you can write it as P2 by P1 equal to P2 by P1 equal to T2 by T1, T2 by T1. So finally, what is the pressure P2? What is the pressure P2? We need to calculate T2 by T1, T2 by T1 into pressure P1. Okay, so in this manner, you will be calculating pressure P2. Finally, will be getting P2 in terms of atmosphere. Here, P1 by P2 equal to T1 by T2, or else P2 by P1 equal to T2 by T1. Now we can substitute the given data in order to calculate P2. See here, thus would be given data. Now P2 by P1 or P1 by P2 equal to T1 by T2. From here, just now we had a discussion. Here we will be getting P2 equals to T2 by T1 into P1 into P1. Here you can write T2 as, what is T2 here? You converted it into Kelvin, 318 Kelvin. What is T1? 300 Kelvin into, what is P1? 30 atmospheric. This is 30 atmospheric pressure. So you want to cancel it. What do people are getting? Here, this is 30. This would be 30. And then you can, this would be, it will become 10. Understood now? It will become 10. Then what is the pressure finally? What is the pressure finally? 31.8 atmospheric. 31.8 atmospheric. 30 tanja, here you will be getting. So it is approximately equal to 32 atmospheric. Okay, na? So this is the pressure P2. They are asking pressure at 3 p.m. Pressure at 3 p.m. That is 32 atmosphere. Final answer to this question, P2 equals to 32 atmosphere. This is pressure at 6 p.m. Pressure in the rigid tank at 3 p.m. Pressure at 3 p.m. This would be 3 p.m. Understood now? So this is the way to solve this problem. So rigid tank is given, that means volume is constant. You can directly apply the proportionality. From here, P2 equal to T2 by T1. You can write this part as, we already know that, you can write it as P2 by P1 equal to T2 by T1. But only thing you need to remember, you need to know, these two temperatures must be from absolute thermodynamic scale. Okay, don't forget to convert it. Understood na? So it is very simple to solve the problem. Final answer to this question is what? This is the given data and this is the formula used. Final answer is 32 atmospheric. So we used this expression P2 equal to T2 by T1, T2 by T1 into P1. So both temperatures must be up from absolute thermodynamic scale. This is the way to solve this simple problem.